Good afternoon. Today we are going to discuss about the manufacturing process and introduction to casting. So first of all, let us understand what is the meaning of manufacturing process. As a part of this syllabus, we are going to deal with two types of manufacturing process. One is casting and another one is machining operation. Okay, so here in the casting we are mainly focusing on sand casting method. So coming back to this, first of all let us understand the meaning of manufacturing process. So what do you mean by manufacturing process? A process in which there will be a conversion of raw material into any useful product which is up to the satisfaction of the customer. That process we call it as manufacturing process. Manufacturing process involves 5 inputs. So we will be having 4 M's and 1 K, that is money, materials, manpower, machine, knowledge. These are the 4 M's and 1 K. Okay. So what exactly is the meaning of this? See here, in any system we are going to have a set of inputs. The best example I can give is a drilling operation. You require money to purchase the machine. You require money to purchase the raw material. You require money to purchase the cutting tool. You require money to pay the electricity bill. You require money to pay the manpower. So money is the most important thing where we are going to use it for this particular process. Next one is material. As I told you, the example of drilling, you require a workpiece on which you are going to drill. So that comes under material. Then we have manpower. You require a person to fix that workpiece, that is the material, onto the machine wise. You need a person to operate the machine. You need person to set the cutting tool. You require a person to remove the workpiece after drilling operation. You require a person to inspect that particular drilled hole. You require a person to do the monetary transaction, that is supply the workpiece that is being drilled to the customer. You require a person to purchase the material. You require a person to load and unload the workpiece on the machine. You require a person to move the workpiece that is being drilled to a packing department. Okay, so everywhere human resource is required. So manpower is the most essential component of any manufacturing process. Then machine. This is that element of the entire process which actually performs the task or the processing on the material. For example, in case of drilling machine is that machine which is going to drill the hole. Okay, so this will be another input. Then you require a knowledge about the process. Okay, the knowledge about the process is most essential because what type of cutting tool to select, what type of speed to select in the drilling machine. Okay, how much depth of cut has to be given. All these things have to be taken care of. Apart from that, from which source the material has to be brought. What are the quality aspects of the raw material? What are the quality inspections that needs to be done once a component is manufactured? So all this constitutes knowledge. Knowledge is the most essential part which can be used to effectively use all these 4 M's. Money, materials, manpower and machine. Okay. So without knowledge, you cannot make effective use of these 4 things. Even in case of an automated factory, you require manpower. A question may arise in your mind that because of the automation, you don't require a manpower. But in actual practice, you require a manpower, but with a reduced number in case of automated factories. So there also you require few people to inspect the entire system. So manpower you cannot eliminate completely in any automated system. Okay. For example, in conventional manufacturing sector, if 100 people are working, in automated sector, it may reduce it to 10 to 50%. Okay. So these are the inputs. What is the output of this? In a system, when we are going to feed these things as the input, what is the output? Output is a product which is going to satisfy the customer needs, or whatever the customer needs, wants and demands will be there, those will be satisfied by this particular product. Sometimes what happens, while making the processing operation or while manufacturing a component, somewhere the process will go wrong or it deviates from the targeted value, and those products are rejected instead of supplying to the customer. Those are called as a rejected product or scrap. Rejected product or scrap. So the products which does not meet the customer specification generally are termed as rejected components. Okay. Even they are termed as scrap. There is another meaning for scrap as well. While in some of the operations, manufacturing operations, you are going to get the scrap material or unwanted materials, and those are termed as scrap, which are not going to be a part of the product. So those are termed as scrap. The best example I can give is, I'll continue with the drilling example only. When we drill a hole in the metal workpiece, there will be small chip formation. These chips does not add any value to the product. These chips are nothing but the scraps. Okay. So this is how the manufacturing process works. I hope you understood the meaning of manufacturing process. Now let us see the classification of manufacturing process. Classification of manufacturing process. Manufacturing process is classified into two categories. One is primary manufacturing process, another one is secondary manufacturing process. In primary manufacturing process, again we have classification called as casting and metal forming. Again we have number of components over here: sand casting, investment casting, die casting, etc. In metal forming, we have forging, rolling, we have drawing, extrusion, etc. In secondary manufacturing process, we have machining, we have joining processes, in this again we have welding, soldering, brazing, fasteners, riveting, etc. Here in machining we have lathe operations, drilling operations, etc. Then we have heat treatment. We have finishing operation. Then sheet metal working. Okay, so here we have two different categories in the manufacturing process. One is primary manufacturing process, another one is secondary manufacturing process. So in actual practice, if you see the things carefully, primary manufacturing process deals with shaping the component, whereas secondary manufacturing process deals with sizing the components. Okay, apart from sizing, in secondary manufacturing process we generally go for giving the aesthetic looks for the product. Okay, so that is where the secondary manufacturing process comes into picture. The most basic primary manufacturing process is casting, and this is the most ancient technology that is known to the human civilization. You can see n number of examples in the ancient history for this casting process. The simple example I can give is the Nataraja statue that they used to make earlier. So way back in before Christ, those are done by casting process. That too by investment casting. Ornaments, swords, weapons, all those they used to manufacture by using casting. So this is the most ancient technology. Till today we make use of this technology for giving the shape to the metal components. Okay. Then in casting again we have different types of casting methods. If we are going to make use of sand to make mold cavity, then we call it as a sand casting. If we are going to make use of wax for making the pattern as well as for making the casting, then we call it as investment casting, where we get good dimensional accuracy. Then die casting, where we are going to make use of metallic cavity which acts as a mold, and from there we are going to get the casting. So those are termed as die casting technologies. Then we have metal forming technology. Remember, the raw material required for metal forming is always supplied by casting process only. In metal forming, we have again different processes. One is forging process. You might have seen the blacksmith's work, where they are going to heat the metal to its red hot temperature and then hammer it in order to give shape to that particular metallic object. That is what is called as forging. Most of the automotive components are manufactured by this forging technology. Again, there are two different types in forging. One is open die forging, another one is closed die forging. Okay. So just remember, in forging we are going to hammer the component in its red hot condition. Okay. Then we have something called as rolling. In rolling, we generally manufacture the slabs, sheets, foils, plates. Those things are manufactured by rolling process. The rollers will be there, big rollers will be there, metallic rollers, and in between these rollers the metal workpiece is passed. Okay, the ingots are passed, and the thickness of those ingots are reduced and the volume will not change. Because of that, the length will increase, and thus we get different types of objects by just reducing the thickness. Like plates we get sheets, we get foils. Okay, so likewise we get the metallic objects of different thickness and different length. Okay, so that is what we call it as rolling. Rolling may be done in hot condition, that is at the red hot temperature, or in cold condition, that is the temperature will be more than room temperature, but it is less than recrystallization temperature of the metal. So that is what is called as cold working or cold rolling process. Then we have drawing. Okay, generally it is done in order to make the wires. So I can give this simple sketch for drawing. So the raw material is fed over here. This is the die, and the material is pulled by using a small opening over here. Wires are manufactured by this particular process. This is drawing. Similarly, for extrusion, we have the die, same die. There will be a small opening, and we are going to apply pressure over here, and because of that metals will be coming out. Okay, just like rods, bars, etc. We are going to get this type of objects. Even wires can be done by this object. The simple principle you can see extrusion in toothpaste tubes. You know, you are going to exert pressure, and through the nozzle the paste is going to come out. In the similar fashion it is done as one of the manufacturing technology. Okay, here the die design is very, very important. I hope you understood this particular part, that is primary manufacturing process. Next, coming to secondary manufacturing process. Once we have given the shape to the object, then we need to size it. You are not going to get the exact dimensions. Okay, for most of the engineering applications you require the dimensions with a very close tolerance. Okay. So with such accuracy you require the dimensions, which is not possible by this methods. So for that reason, whatever the components that are processed over here are transferred to secondary manufacturing process in order to get the dimensions, as well as in order to get the good aesthetic look, as well as in order to get the mechanical properties or change the mechanical properties. Some mechanical properties are not better in these processes, those will be enhanced by secondary manufacturing process. The first and the foremost is machining. Okay, most of the times what happens in casting or metal forming, we get unwanted projections. Those are deburred, those are removed. Okay, those are done by machining processes. In some of the conditions we require the object in certain different geometry. Okay, for one or two components you cannot make use of this casting or metal forming process. So what we do is we take a standard component that is manufactured either of these two processes, and then those are machined. Okay, for example, in the market if you are going to get 20 mm bar, but for your engineering application you are going to use 19 mm bar, 19 millimeter bar. So at that time we are going to reduce the diameter. Okay, so for that we make use of lathe operation. In that lathe operation we call this operation of reducing the diameter as turning. Okay, in certain cases you require the tapered shafts like this. Okay, so this type of objects can be easily manufactured by using circular workpieces by something called as taper turning operation using lathe. Okay, so this you have already done in the lab. So this is what we call it as taper turning operation. Okay, mild steel bar, if I want to convert MS bar into this particular geometry, that is, for example, if it is having a diameter of say 20 mm and we require this part as 19 and this part as diameter of 12 mm, so that can be done or converted in this particular fashion by making use of taper turning operation with certain taper turning attachments or swiveling the compound rest in lathe machine. Okay, as I have explained in the earlier section of the lab, lathe is considered to be the mother of all the machines, as we can do number of operations by using this lathe machine. Then drilling operation. Drilling, again we are going to drill a hole inside the objects. Okay. So there are different types of drilling machines. One is radial drilling machine that you have seen in our lab. Apart from that, we have a portable drilling machine which we make use of for drilling the holes in the walls as well as in the wood. Okay. Again, there are different types of operations we do in drilling. Okay. We are going to again, enlarge pre-drilled hole. That is what we call it as boring. We are going to enlarge only the head part of the hole like this. If this is the pre-drilled hole, then I am going to enlarge this part, or I am going to make a conical section so that this screw can be fitted inside this. This is called as countersinking operation. Like this, many types of holes can be drilled. Also, I can make threads over here. Threads are the external grooves on the screws, and this can be, when we insert this, you require a grip, so those threads can be done internally for this particular hole. Okay, so that is what we call it as tapping operation. So these are different operations we perform. Apart from that, there is a milling machine, there is a shaping machine. Okay, and different types of machines we make use of as a part of machining operation. Then we have something called as joining process. You cannot manufacture a component in one go if the dimensions of the components are very big. Okay, so at that time what we do is we divide this particular product into a number of small elements, and these elements are manufactured independently. Those are brought to the assembly site and those are assembled. Assemble in the sense joining the materials, okay, or fitting the materials. So this is done by using this joining process. Again, we have n different types of processes in joining. One is welding, that is what almost all of you have seen, electric arc welding in the lab, as well as you might have seen the gas welding process. Okay, so welding is a permanent joint where we are going to join two metal components. Okay, apart from electric arc welding and gas welding, we have laser beam welding, we have electron beam welding, we have friction welding. Like that, different forms are there, and those technology we make use of for different material composition as well as different applications, and also it depends upon the thickness of the workpiece that we are going to join. Then we have soldering. Okay, especially this is used for sheet metal works, where we are going to join the sheet metal. Okay, so that also you have done in the lab. Brazing, when we are going to join the metals at an elevated temperature but less than the melting point of those components, then we call it as brazing. Okay, so brazing is similar to that of welding, but only thing is filler metal will be having different composition as that of the workpieces. In most of the welding tech processes, we are going to have the filler metal. Wherever we are going to make use of, those filler metal will be having the same composition as that of the workpiece, and the temperature in welding will be nearly equal to the melting point of those workpieces. Brazing is a weaker joint as compared to welding. We will come to this particular difference between welding, soldering and brazing in unit number 4. Fasteners, screws, nuts, all these are called as fasteners. Then we make use of rivets. Then there is something called as adhesive bonding. We make use of chemicals to join the materials, so that is where we make use of adhesive chemicals, so that is what we call it as adhesive bonding. In certain cases, what happens when metal undergoes the forces over here in metal forming or thermal stresses in the primary manufacturing process or even in the heat treatment process, even in the machining process, then the properties of those material has to be enhanced, or the stresses that are developed in the earlier manufacturing process has to be relieved. So in those conditions we go for heat treatment. Okay, we are going to heat the materials to their recrystallization temperature, and then we are going to cool it to the room temperature. You know, there are again different techniques like normalizing is there, annealing is there, quenching is there. If suddenly we are going to dip the metal in the water after heating it to its recrystallization temperature and allowing it to settle there for a certain time and then immediately quenching it or immediately cooling it in a water or oil, we term it as quenching. Okay, by such processes there will be change in the mechanical properties, and those are done by this heat treatment process. There are again, you know, something called as a case hardening process. Okay, like that, different types of heat treatment processes are there. Next we have finishing operation. So in finishing, what we generally do is we are going to make the surface smooth either by painting or polishing. Okay, some projections will be there; those can be deburred. All these things are done in finishing operations. Okay, even galvanizing, coating can be done. So those are considered in this finishing operation. Then sheet metal working. The sheet metal, whatever is manufactured by rolling process, has to be used. Okay, so that is what is done. The shape is given to this sheet metal by bending, punching, pressing, or coining. All those things are generally done by this sheet metal working. Okay, so this is in totality the classification of manufacturing process. Okay, I hope all of you have understood this. Okay, next part is casting. So we are mainly focusing on casting, introduction to casting, in that only sand casting. Okay. Casting process. See what is casting. Then advantages. Disadvantages. Applications. Okay. Next we have classification. Casting process. And in this we have two classification: expandable molds we have permanent molds. Okay, we have permanent pattern again in this. We have expandable pattern. In again permanent molds we have expandable cores, we have permanent cores. Example for this are die casting, then we have centrifugal casting, etc. Okay, so let's see one by one. So first of all, let us understand the meaning of casting. So casting is a process where we are going to pour the molten metal in a cavity. Okay, cavity is the negative replica of the object that we want. Okay, for example, I want a metallic object like this. Okay, a rectangular slab of say 100 mm by 150 by 25 mm. I want a metal object like this. In order to make this, what we do is, we are going to take a mold box like this, and then over here, okay, there will be a hollow cavity of this dimension, say 100 by 150 and this height will be 25 mm. So what we are going to do is, we are going to pour molten metal. These are the sand particles. This consists of sand, grains, clay, water. Okay. So this is the most simple example I am giving. What is the meaning of casting for that particular definition? In casting, we are going to pour the molten metal in the hollow cavity called as mold cavity, and then this molten metal is allowed to solidify in that cavity. Once solidification is done, we are going to break the sand mold. Whatever we get, the solidified metal will be having the internal shape of this mold cavity. Okay, that is what is called as casting. In order to get this dimension, we are going to cut the sand block with this particular dimensions, 100 by 150 by 25. Actually, in actual practice, the metal as cools, it shrinks. So for that reason, we give the cavity dimensions more than that. For example, here in this case, we are going to give it as 110 mm by 162 mm by 27 mm. Okay. Then when we pour the molten metal, when it shrinks, we are going to get nearly this particular dimensions, not exactly, nearly. So this is what we call it as casting process. So just keep it in mind, casting is a process where we are going to pour the molten metal in the mold cavity, and after solidification we are going to get the casting. Okay, the place where casting is done is called as foundry. Okay, foundry is the place where castings are prepared. Okay, there are certain merits and demerits of this particular process. First, let us list the advantages. The process is simple. The process is economical for mass production and batch production. Okay. The metals which can be melted can be casted. Any metal you take, whatever metals which we can melt, those metals can be casted. Okay. Then the complex geometries can be easily manufactured by making use of casting process. Okay. In certain cases, even we can avoid machining. Okay. For example, if on this particular block itself, if I want to drill a hole of say 70 millimeter diameter, so in those conditions, instead of going for drilling a hole, we can make use of a simple sand core. A sand cake which is used to make the hollow cavities are termed as sand cores. So that we can make use of instead of drilling a hole once the component is manufactured. So instead of drilling a hole in this particular slab, just we are going to place one sand cake at the exact location of this. So what happens, molten metal occupies this space but not this space. So that is why the hollow cavity will be formed. Okay, like that you can get the shapes very easily. Okay, the complex geometries can be manufactured easily. In modern technology, we make use of certain chemicals instead of clay and water. Here I have mentioned something called as clay and water. You cannot simply take fresh sand and make a mold. You require an external agent which makes the sand grains to stick together. So that is where we make use of clay. Okay, clay is termed as bentonite in foundry terms. Okay, again there are different types of clays. So it depends upon what type of metal we are going to cast. On that basis, we generally select the clay. So here clay acts as a binding agent, but this clay has to be activated. So that is done by using water. Okay. So wherever we make use of clay and water as a binding agent in casting, that process we call it as green sand casting or green sand molding. Okay. But in order to get a near net shaped casting, we make use of chemical binders. Okay, chemical binders, if at all we want to list, are something like phenol formaldehyde along with p-toluene sulfonic acid. Phenol formaldehyde acts as a binding agent, whereas p-toluene sulfonic acid acts as a activator. Okay, we have something called as furan or furfurylic alcohol, which is used along with p-toluene sulfonic acid. Okay, esters are used, oils are used. Linseed oils can be used as a binding agent. Earlier they used to make use of the molasses. Okay, whatever the canons you see when you go to the historical places like forts and other things, whatever canons you see there, those are all casted. Those are generally made by using this molasses. Okay, that is the agricultural product what we generally get. So that can be used as a binding agent. Okay. So likewise different binding agents are used. So near net shaped castings we are going to get by this casting process. Okay. The drawbacks of this process are, just like other processes, every process has its own merits and demerits. The drawback is the initial investment. It is very high. You require a large space, you require a melting furnace, you require the labors. Okay. So all these things are required. So investment is very high. Then it is labor intensive work. You require a labor. It cannot be completely automated. Okay, that is one of the major drawback of this process. Second one is, it is not eco-friendly in most of the cases. Okay, as the gases are going to generate because of the solidification of the metal and also because of the burning or combustion, also because of the chemicals that are going to burn because of the elevated temperature of the molten metal. If we are going to make use of chemical binders, or in case of clay and water, they are also going to generate the gases in case of solidification or when they come in contact with the high temperature molten metal. Okay, we term that as a gas evolution generally. So that is one of the problem, because whenever we make use of chemicals as a binding agents, so the health issues related to the worker is a major concern there, because the harmful gases are generated and this may affect the health of the worker. Okay. Then it cannot be used for job shop production. Okay. For one component or two component, you cannot go for casting. It is uneconomical. So that is one of the demerit of this particular process. Applications. Almost all the raw materials required for another manufacturing processes are manufactured by casting. The automotive parts are also manufactured by casting, especially the big parts that you see in the earth movers. Okay, the beds of the machine, the rigid body, whatever you see, the anvils I hope all of you have seen, the anchors of the ship, those are all casted. Okay, the application of casting is in marine applications we get, in space applications we get it in automotive application, structural application. Okay, likewise a number of applications are there for casting process. Then classification of casting process. So how the casting process is classified? Here basically one of the best classification that I have shown is expandable molds and permanent molds. Expandable molds in the sense, once casting is prepared, we are going to break the mold. The molds are not going to stay permanent for the next pouring. So that is what is the meaning of expandable molds. Okay. In expandable molds, again we are going to have something called as permanent pattern and expandable pattern. First let us see the meaning of pattern. So in this example, I have shown a cavity is first created and inside the cavity we are going to pour the molten metal. But the question arises, how you are going to make the hollow cavity over here? So that is done by using something called as pattern. Okay. So pattern is an object which is having a geometry as that of the casting that we require, but with slightly higher dimensions. So these patterns are made up of wood, plastic, rubber, metals, okay, then wax, all these things are used for making the pattern. In this simple example, I can show if this is a bench, then first I am going to keep the pattern on this. This is the front view. So you can see the dimensions of the pattern. So I require the dimension here as say 110 by 165 by 165 by this one 28 mm. So this will be 110. This will be 165 and this will be 28. So this, in this case, considered to be a wooden pattern. This is used over here. It is put on the bench and there will be a metallic box, a hollow box like this. There will be a hollow box. Okay, so this is the box. Here, box, we can call it as pattern. This box is termed as flask. Okay, so this sand mixture, that is sand, clay and water, are mixed in a mixing machine called as sand muller. This mixed sand is then put in this particular flask. So this sand grains occupies the void spaces and whatever is there on the pattern, that void space will also be occupied by this. Okay, then this particular box or the sand is rammed using a rammer. Okay, so once it is rammed, this entire box is inverted and the pattern is taken out. So what remains is This is the pattern, and this pattern is taken out. What remains is the hollow mold cavity. This is the mold cavity. So this mold cavity is then used for pouring the molten metal. Okay, and then it is allowed to solidify. Once it solidifies, then we are going to break the sand grains over here. That is what we call it as shakeout operation. And once that is done, we are going to get this solidified casting. Okay, but whatever pattern we have used in this example can be reused for making another casting. Okay, that is what we call it as permanent pattern. Okay, so the pattern can be reused for next subsequent products, next subsequent castings. So that is where this term comes is permanent pattern. In most of the sand casting process, we make use of permanent patterns, and these are made up of metal and wood. Even nowadays they make use of plastic patterns as well. 3D printed patterns can be used. Then we have expandable pattern. Expandable in the sense, as I told you, we are going to break. Okay, we are going to destroy. Okay, so the patterns are destroyed in the process. So that is what we call it as expandable patterns, wherever we are going to break the pattern. Okay, the best example for this is the wax pattern. In investment casting, we are going to make use of wax. Okay, once the wax patterns are used, they cannot be reused for next casting. Again, the wax has to be given the shape, and that shape can be used as a pattern. Okay, so that is what is expandable pattern. Next we have is permanent molds. In this case, we are going to break the molds, and in this case, we are not going to break the molds. Instead, we are going to reuse the molds. Here, the metallic molds are used in this case, in case of permanent molds. The best example I can give is the permanent gravity die molding. In gravity die molding, there will be a die made up of steel, generally die steel. These are generally done in order to manufacture aluminum castings, small sized aluminum castings. So whatever cavity is required, that is machined in this particular die steel raw material. Once the cavity is formed, we are going to pour the aluminum, and we are going to remove the casting once it solidifies there. Okay, so basically here, whatever the permanent molds we are going to make use of, they have higher melting point than the metal to be cast. Okay, that is what is called as permanent molds. Again, we have something called as expandable cores, generally made up of sand, and we have something called as permanent cores, which are made up of metal itself. Okay, so these are the classifications. We have something called as a centrifugal casting, we have continuous casting as an example for this permanent molds. So this is all about the classification of casting process. Okay, next we will see the structure of the sand mold. Structure of the sand molds. Okay, sand casting molds. So in most of the cases, the metal has to be made to flow through certain channels, not directly. So that is where this part is going to come. Structure of the sand molds. We have pins over here for alignment. It's called as a flask, both the things. Then we have this line called as parting line. This is the riser, and we have a simple sand core. Okay, so this is pouring basin. We have sprue base, riser, a core, mold cavity. There is something called as a runner, and here this part is a gates and ingates. Okay, and the casting, whatever you get, it will be having this structure. So these are the elements of the sand casting. This is the cross section of a typical sand mold. So here, instead of pouring the metal directly like this inside the cavity, if this is a cavity, instead of pouring it directly, the metal, as metal will be having its own density, or self weight will be there, and with the help of acceleration due to gravity, when the metal falls, this mold cavity will get damaged. For that reason, we make use of these channels. Okay. So first part is the pouring basin. This part acts as a guide for the person who is going to pour the molten metal. Generally, to pour the molten metal, we make use of an equipment called as ladle. Okay, ladle is that equipment which takes the metal from the furnace, and then it is used to pour the metal inside the mold cavity. Okay, so with the help of a ladle, we are going to pour the molten metal inside this pouring basin. It is just like a funnel. Okay, so for example, what happens when we directly try to put the petrol from a bottle directly into the fuel tank of your vehicle? Okay, it will spill here and there. So what we make use of is a funnel, right? It will direct it. So that is how the pouring basin will work. Next one is sprue. From pouring basin, the metal flows to the sprue and then to this particular part called as sprue base, where actually whatever the impurities that may be present inside the molten metal will be stopped over here. Okay, and then the molten metal flows through this runner and then into the mold cavity. But I require a hole exactly at this particular location. So what we do is we set the core, or we fix the core. Fixing the core inside the mold cavity is called as core setting. So that is done over here. Okay. In order to make sure whether this mold cavity is filled or not, we make use of another component called as a riser. These are all hollow channels. Okay. So after the molten metal fills the mold cavity, the molten metal is going to come out from the riser. Please remember, this is the last part that is going to get solidified. Okay. This not only helps the person who is going to pour to see that whether mold cavity is filled or not. Apart from that, whatever the metal that is going to contract or shrink once it solidifies or during its solidification, that has to be compensated, and to compensate that shrinkage, this riser will feed the metal. Okay. Apart from that, riser will also help to allow the gases to pass through this particular channel. Otherwise, what happens if gas is going to remain inside the mold cavity, we are going to get defects. Okay, small craters will be formed on the surface. The smaller craters are referred as pinholes, the larger craters are referred as the blowholes. Okay, there are again n number of defects in the casting. The best example I can give is over here. When we pour molten metal directly, the sand is going to come out from the surface and it is going to accumulate on the molten metal. Okay, wherever the sand grains are accumulated, there the craters will be formed. Such craters are called as sand drop problem. Okay, again sometimes what happens, the impurities, if they are not filtered before the molten metal reaches the mold cavity, then there will be a defect called as sand inclusion, which will hamper the machining operations in the further stage. So all these aspects has to be considered. Okay, so here you can see, once the casting is solidified, you are going to get the metallic casting like this. Along with that, the riser, where this some portion which is not present over here, or the dimension is reduced, it is because it has fed the molten metal to the casting. Okay, this line is called as a hatching. The hatched line indicates the solid part, whereas unhatched part indicates the hollow part. In reality, if at all you want to see it in the isometric wave, this is something like this. Okay, so this is the component and this is the hole. Okay, so this is how it is going to be seen. The process in which we are going to remove this part as well as this part, because here also you can see the metallic object. What happens after pouring, some amount of metal also gets solidified over here once pouring is stopped. Okay, after a certain interval of time, whatever metal that has been accumulated over here also gets solidified, and that is the reason why we get something like this irregular shape over here. These things, unwanted things, has to be removed. These are done by grinding process, and this process we term it as fettling operation. Okay, keep it in mind, breaking the mold once solidification is done is called as a shakeout operation, whereas trimming the gating system or removing the unwanted projections like gating system and a riser is termed as fettling operation. Okay, so these are the sand casting molds and how its structure will be. Okay, next we will see the steps in sand casting process. Steps in sand casting process. Melting, sand preparation, then we have core making, core box making, then we have melting. Again we have pattern making, then sand molds are done.